So interval estimator. So from central minimum theorem, we know that sample mean when n is large will be approximately normal with mean mu and sigma square over n, right? So and we know sample mean is a good estimator. Also, we know it's a good estimator. So, but instead of giving you x bar, right? Can we have a more? Can we say more? Okay. So can we? What we want to do is a estimate interval. So how does it proceed? So first we'll define an alpha, okay, which is a parameter, okay, a parameter. We have to design. So we will try to, given this parameter, we found a symmetric interval over the mean. So what's the meaning of this parameter? We want this alpha parameter, okay, is 1 minus, we want to find a C, okay, such that the normalized mean, okay, will be between this plus C and not negative C. So remember this is a mean 0. So it's normalized Z, right? It's standard normal. It's between this C and negative C, okay? And the probability will be 1 minus alpha, okay? So if you try to figure out this, right? This is Z, right? Z, right? So if you notice this, okay? And Z should be Z of alpha over 2, right? This is a tail. Normal, standard normal, the tail is called alpha over 2, okay? And we can rewrite this as negative Z is alpha over 2, right? It's between, probability is 1 minus alpha. And multiply both sides by sigma over root n and plus mu, right? So the unknown mean, right, will be between x bar plus minus this plus minus z alpha over 2 and sigma over root n, okay? So that's why we'll call this is interval estimator, right? And the meaning of this is on average this there will be 1 minus alpha probability that our estimator, okay, will include the mu, okay? Remember the mu is unknown, but it's not probabilistic, okay? It's not random variable. What is random variable is x bar, okay? Here, every sigma is assumed to be known, okay? N is something we know it, right? X bar is something depend on the sample you draw, okay? So just say this random variable, okay, fall within mu, okay, will have probability 1 minus alpha. Okay, so that's the idea. So to summarize, what is the confidence interval estimator is 1 minus alpha percentage. Okay, confidence will be x bar plus minus ZO alpha over 2 sigma over root n. Okay, and we call this guy is margin of error ME. Okay, and the width interval, because it's plus and minus, so it's 2 times of this, okay? And confidence interval will be, the lower limit will be x minus the ME, upper with x plus ME, okay? So the meaning of confidence interval is a little bit complicated, right? Because of the fact that we are saying the probability of this interval, okay, has probability 1 minus alpha. But the thing is, this probability would make sense if we repeat many times and we can say the probability, but we just do it, right? There's no more probability, okay? What it actually means is, suppose we do this sample a lot, okay? And we do enough sample, and it means 95% of them, okay, of this interval, we include the mean, okay? So it means if you standardize normal, if you do once this interval include the mean, okay, this include the mean, this include, but this not, this is not. It means if you construct, say, 100 of them, okay, 95 of them is included the mu 0, but 5 of them does not. Okay, that's the meaning of confidence interval. Okay, let's give you example. So consider population standard deviation is 4. Okay, a random sample of random sample size the 64 and the sample mean is 3. Let's construct a 95% confidence interval. Okay, the point estimate is very simple. The sample mean, right, and the sample is 3. Okay, and look at the z table. The tail 95%. Then it means alpha is 0.05. Okay, 0.05 divided by 2 is 0.025, is 1.96. So marginal error is 1.96 times 4 population over the root 64, so it's 0.98. Okay, so that means the 95% confidence is 3 plus minus 0.98. Okay, so that is the idea of interval estimator.